Today we have accelerated for the first time a beam, an H- beam, through the Linac 4 RFQ. This is an accelerator that is meant to replace the Linac 2 in the LHC injector chain. And today we have opened the valve connecting the RFQ to the ion source, have let the beam go through and being accelerated by the accelerating field that is inside the RFQ. So this RFQ is a very peculiar accelerating cavity that takes the beam at very low energy, so at 45 keV, and is able to accelerate up to 3 MeV. Here we are in front of the ion source where the story starts. So everything starts from a gas bottle, a nitrogen gas bottle, that is injected into an ionization chamber where the plasma is formed, and then from the plasma the H- ions are extracted at an energy of 45 keV, ready to be transported to the low energy beam transport line. This is the low energy beam transport line. You can recognize in violet the two solenoids that are there to focus the beam at the entrance of the accelerating structure. This is the accelerating cavity. It's a radio frequency quadrupole, so-called RFQ. The beam is extracted from the RFQ at the energy of 3 MeV through that valve, and then is transported along this diagnostic line. And the current signal that we saw here on the scope was coming in fact from this beam transformer. So some 60 centimeters after the extraction from the accelerating cavity. We have a spectrometer magnet. It allows to perform a precise measurement of the beam energy and of the energy spread of the particles inside the beam pulse.
On the screen you can see the yellow line represents the signal, that is the particles as they're coming out of the source. Here is like we are catching them on a trap just as they are produced out of the source. And then from this point they are transported through the RFQ. Here is the signal of the particles that are coming out of the RFQ, and they are seen by another detector which is on the other end of the RF structure.
From this small control room we control the RF power that is sent to the accelerating cavity, so to the Linac 4 RFQ. In this room we have some low-level electronics that has the role of keeping the accelerating field inside the RF cavity at a stable level for the beam acceleration. And then we have some monitoring that allow us to check that the power level inside the cavity is the appropriate one, like this spectrum analyzer, or on this oscilloscope we can monitor the vacuum level inside the accelerating structure in pink and in the power coupler in green. And then we have a direct value of the power that is sent to the cavity for the acceleration of the H- beam, which is around 430 kilowatts.